Yeah, this is like, watch old grandpa trying to work there. I'm going to turn the camera on. One of the big mistakes I'm seeing is people are doing this kind of magical thing. Please tell me. Your brain wishes that was true, right? Because then you can get rid of some of the shit. Let me get rid of this shit, John. I got rid of the shit there. Why can't I get rid of it here? Because subtraction is not the opposite of division. I mean, it's that simple. Don't say, why is math different often? No, math says if the operations are the opposite, then they will cancel. That makes sense. The operations here are not opposite. Therefore, they won't cancel. See, math is not different. It says the same thing every time. I like it. Anything else from the quiz or homework stuff?
Homework.
Yes,
Okay.
Homework.
4.5, 387.
Let me see if I can find 3. Oh. That's right. So you're not telling me the page number, you're telling me. Here it is. It's got to be right there, Jeff. Oh, thank God.
360 or 360.
Oh! Okay. I'm with you. Okay. Oh, look at those. Just like new fallen snow there. Now it ain't hot. So this is another situation where letters come into play. Let me ask you what seems like possibly an unrelated question. If I had negative 33 minus 8x, can I combine those?
No.
Why not?
They're not like terms.
They're not like terms. I got negative 33 ones minus 8 x's. I can't combine those. I can't consolidate those ideas because they're two different ideas.
But if it was multiplication, you could do
Totally. I could do negative 33 times 8x. I could just do negative 3 times 8. So multiplication is a little looser with its restrictions, right? So that's not entirely unrelated to what's going to happen here. What's the LCD here? I can't combine these fractions unless I have LCD. What is the LCD going to be?
88.
Yeah. What's up?
Oh, nothing. I couldn't figure it out.
Gotcha. So you don't care about this at first because your whole world is all about making the bottoms the same. The little part of your brain is going, there's an X, and you're like, shut up. I just got to make the bottoms the same, right? They don't share anything, so they need each other. Aww. So this guy needs an 11. This guy needs an 8.
Oh, that's where the 8
So what's this? Negative
33.
33 over 88 minus 8x over 88, right? But now they're both over 88, so I can combine them. I can't combine the tops, really, because they're not like terms. But I can say whatever it is, negative 33 minus 8x is, whatever that is, it's over 88. That's really what we always do. What's 4 sevenths minus 1 sevenths? 4 minus 1 over 7. Oh, 4 minus 1 is 3. I can go one more step. Here, I can't go that last step. And of course, we often do this idea in our head. But remember, that's totally what's happening. So if I write this and I go, I can combine those. Circle it. You're done. I like it. Yes?
Why did you use the 8 for all both of them?
Do it again, sorry?
Why did you use 8 for top and bottom for X and 11?
All right. That is the only thing I can do to make it legal. I can't change this number because then it's a different problem. I really want you to understand. When I do this, I am actually not changing anything. I'm changing the way it looks. Negative 33 over 88 is 3 over 8, right? Negative. So what did I multiply this one by? 1. 11 over 11. So when I multiply by 1, do I change it? No. It looks different. But if you did 33 divided by 88 and 3 divided by 8 in your calculator, same number. I like it. Same thing for this one. It needs to be 88 on the bottom, so I'm going to multiply top and bottom by 8 to make it legal. If I only change the bottom, I've made a different problem. It's not the same problem anymore. Right? So I thankfully I haven't seen too much of this kind of thing 4/5 minus 1/3, and then somebody makes it 4/15 minus 1/15. Do you see what this person did wrong?
Yeah. Didn't do
They
it.
said this becomes this. What did they do wrong?
Forgot to do it to the top.
Yeah, they forgot to do it to the top. They're trying to say 4/5 equals 4/15. Well, holy shit, that ain't true. If you divide 4 by 5, do you get the same thing as 4 divided by 15? No.
It would be 12 or 15.
Yeah, so this shouldn't be 4, this should be 12. This shouldn't be 1, this should be
Or 5, right?
5. Yeah. 12 divided by 15 is 4/5. They're the same thing. 1/3 is 5/15.
And
They're the same
and
thing.
the answer would be 7 over 15.
7 over 15, 11.
Could you do that problem? Like another problem like that, similar? The one
This one?
Yeah.
Okay. Let's do one that's got a more interesting LCD. Let's pick another letter besides Y, Jeff. I was looking for. There we go. That doesn't matter, Jeff. So what's the LCD going to be here? 15. So what did you multiply by what?
Times 3.
Yeah, this needs a 3 on the top and the bottom. So you get 3m over 15 minus 7 over 15 is
It's 3m minus
3m minus 7,
over 15.
15. Because these are not like terms. Whatever 3m is, what would you do to it to work this out? You would subtract 7 from it. So whatever 3m is, I'm going to subtract 7 from it and put it over 15. I'm like telling somebody else what to do. Hey, if you figure out what m is, this is what the hell you do. That's really what that means. So don't tell me negative 4m. That's some magic stuff, man. It's no good. You guys with me? These are not like terms. Yes?
So what mainly is just you have to get 15 or 5 to be like this, get them to be
The same number,
same,
exactly.
yeah.
What do you multiply them up to be so they're the same?
Uh-huh.
So that doesn't change. Just because I got a letter sitting in there somewhere does not change that idea. You guys cool? And really just look at this. Isn't this 3 times 5? And that's how I knew this needed a 3. Because it already has the 5, right? Or some of you guys are like, I knew it needed a 3 because that's what makes it 15. Okay, good. That's a good way to look at it too. So there is one problem in the homework that's a little more interesting than this. And when I say interesting, that normally means complicated. So we got this what they want here? So there's a homework in the problem. There's a problem in the homework that looks like this here. Homework in the problem. I like that, John. There's a homework in the problem that looks like this. The chalice from the palace holds the brew, which is true. Danny Kimberly. Now this is weird, right? It's like, don't be putting no freaking variables down there, Joe. What the hell? But if this was a 9, like it sort of looks like, then what would the LCD be?
36?
4 times 9. Because 4 and 9 don't share anything, so they need each other. Well, 4 and A, I don't know if I'm going to have to assume that they don't share anything, because I don't know what the hell A is. Does 4 have an A in it? No. Does A have a 4? No. So what is this guy missing? An A. And this guy's missing a 4. Do you see that? Realize what the idea is. Sure, when I throw variables in places that you're not used to seeing them, your brain's going to go, wait. But the idea cannot change. It can't. Because what is a variable?
A number.
It's a number. Number I don't know yet, but it's still a number. It's got to act the same way as any number. So what would the answer here be? It would be 3a minus
28.
28 over
4A.
4a. Yeah.
I have another variable question.
Okay. All right.
Page 393.
Page 393. Yeah.
Page number 528.
Oh yeah. All right.
I didn't know where.
So let's start off with the one that didn't have fractions in the way, but it has the idea. That's important. So let me build up to this. How do you solve a problem like Maria? How do you solve that? I'm going to build up to it.
Get X by.
So what exactly would I do to this equation?
Divide by 2.
Divide by 2, because I'm trying to uncover what the x was. Somebody doubled it, I'm going to cut it in half. So I can make x by itself again. So nothing amazing there. What if I had negative x equals 14? What is actually here that we just don't write? A 1. So if you want to put it there, now it's just like there's a 2 there you don't want, you divide it by 2 because it's times. This is times, there's a negative 1 I don't want, so I'm going to do what? How do I get rid of the negative 1? So that cancels. X equals negative 14. Cool. So in that problem, you do the exact same thing. The really funny thing is, I really want you to, if I say negative x equals 11, then the answer is x equals negative 11. See how the negative just, I just changed the signs on both sides? If I divide by negative 1, it's going to change the sign. So if I had negative x equals negative 12, x equals 12. Divide by negative 1, the negative is going to cancel. So that last thing is really going to make that problem quick. Because the only thing that's you need to get rid of is that negative. Yeah.
Okay.
I like it. So anything else from homework or quiz? Yeah.
Page 378, number 492.
Oh yeah. Okay. I like this problem. I don't want to say too much because it's in people's future. But if you draw this, it might help out a little bit. Something like this. So this is number 4, what did you say, 492?
492.
492, yeah. So if I had a sidewalk that was, what do you got? Let's say 5.5 feet wide, right? And I had grass here and here. The grass, let's say, is 1.5 feet on both sides. How would you set up the math to figure out how wide this is total? From edge of grass to edge of grass. Do you guys get the idea? So I got a sidewalk. I know how wide that is. I plant 1.5 feet of grass on either side. Now how wide is that total thing? Grass, sidewalk, grass. How wide is that whole?
5.5 plus 1.5 times 2.
Yeah, 5.5 plus 1.5. Yeah, you could do that, or just plus another 1.5. Either way you want to do it. Yeah.
What is his figure? Tell me if I half. You take me 8 halves for all of them.
Yes, I love it. I know.
Different is.
I know. Just a little bit different.
Yeah.
That's because I want to leave something. But this idea is adding stuff on.
Yeah.
This one is you know the total area,
So,
and you know how much you want to subtract. It's the same idea, just I'm going the other way.
I will do it.
Good.
I will do it.
Do it.
But I have other people in your town.
Oh, I see. Okay. Well, that's all I'm going to say. Yeah. It's a lot like this problem, just on that problem, you know this total area, and you know how much you're going to... It's sort of like if I told you this whole thing is something, I'm going to plant grass here, how much is left over for the sidewalk? That's what that problem is like. But I desperately want to leave something for you guys to do. Okay, so drawing the picture might actually help out a lot for that one. Okay, all right. So that was for, what section is that? 4-6, number 492. Anything else from homework, quiz, anything? Okay. A few more people came in. Anybody else still need the first part of chapter 5? I'll have the second part on Thursday. So we haven't actually gotten into chapter 5 until right this second. We're about to get into it. Okay, here we go.
This is second part or the first part?
First part. Second part I'll have on Thursday. And by the way, we're probably going to just do, I'm almost certain we'll only have time to do one section out of the second part. And then the test will only go that far. You guys with me? You understand? Yeah, so I can always adjust the content on the test because I'm the guy who makes it. So I don't think we're going to have enough time. And with the spring break coming up, I don't want to push the test back. Everybody. Have you ever had a teacher give you a test the day you got back from spring break? Have anybody ever had that? I have. I have not been that teacher yet. Give me a few more years, I might get students. I'm going to get them. No, I'm just not like that yet. I keep saying that. I've been teaching for, oh my God. I've actually been teaching for 19 years. Oh shit, I just felt old, really old. I started teaching when I was 26. And I looked like I was 16 or something. So I would sit out in a seat in the first day of class. I would sit out there and everybody come filing in. I'm like, hey man, you know anything about this teacher? Thankfully nobody's like, yeah, he's a real asshole. Because then I'd get up and start handing the syllabus down there, all like, what the hell's going on? Can't really do that anymore. All right, so there's no more questions on homework or the quiz. Let's get into chapter 5. All right, so let me start really with the basics, the pure basics of decimals. Enough. All right, now watch. What place is the 4 in? Hundreds. What place is the 5 in? Tens. Notice from 100 to 10, what do you divide 100 by to make it 10? 10. Because every step in our number system is based on 10. More than likely because we have 10 fingers, and the most natural way to count something is like this. Which is really weird. If we had 12 fingers, we'd have a number system based on 12. Let's not think about that too much. So this is the tens. So of course this is the 100 divided by 10 is 10 divided by 10 is 1. So this has to be divided by 10. What is 1 divided by 10? 1 over 10, which you say as...
1/10.
Good. So this is the tenths. That's the 10th spot. So this would have to be the hundredths.
Just going the other way.
1/10. I keep dividing by 10, dividing by 10. What is 1/10 divided by 10? It's 1/10 times. You can do it. Come on. 1/10 divided by 10 is 1/10 times
10 over 1.
1 over 10. You got to flip it. It currently is 10 over 1.
Oh, that's right, yeah.
Flip it now. It's 1/10, which becomes hundredths. So this is the hundredths.
So if that's the hundreds, what's the other way again? What's that one called? The other hundreds?
You just say it without a lisp.
Oh, okay.
Right? This is the hundreds. This is the hundredths. Right? So you get a lisp back here. Right? You spit on people. Don't let the tenth. Like, holy crap. You guys with me? All right. So some of you guys know this all too well. Some of you guys, it's been a while since you really looked at this directly. So what would the next place be?
Thousands.
Thousandths. I love it.
Thousands.
I like it. Thousandths. Yeah, cool. All right, how are we doing so far? We decent with that? Okay, good. I like it. So just to go a little ahead, just to go a little out of order from this book, how would I say this? 7/10. And isn't that just a fraction? How do you write 7/10 as a fraction? 7 over freaking 10. I love it. So I think I've said this once in this class, but decimals are just special fractions. Decimals are fractions that fit into our base 10 number system. So any fraction whose bottom is based on 10, 10, 100, 1,000, and so forth, fit into our base 10 number system, so they have a place in a single line of numbers. Does that sort of make sense? So if I have 2/5, does that fit somewhere? Not really. Not I can't put a 2 somewhere and have it make sense. It's 2/5, right? I really want this to make sense. So if we go the other way, 2/5 is how many tenths, though? Yeah, I multiply by 2, which is, how can I write that as a decimal? 0.4. I love it. Or just 0.4. Why do we put the 0 in the front? Just to make sure that people realize there's a decimal there, because that little point gets lost real easy. But you can write it really either way, but that's just being more careful. All right, how do we feel so far? Does this feel familiar, or what's up?
No, not familiar at all.
No.
Does it make sense?
Nope.
Well, shit. All right. So just to remind you guys, the minute I lose you, obviously don't feel like you're alone. Because if you don't understand, I will bet money, and I am a teacher, so I have a lot of that to go around. I will bet money that at least 8 other people don't understand either. So you got to speak up the minute I hit something. So how do we do on this first part?
I don't get it. I understand that part, but how do you... So let's say the decimal is where it is right there.
Yes.
So if I want to name that decimal place, is it the one behind it? Is it the one...
No. There's no name for this. That is just like a comma. When I write 4,000,
You're right.
what place is the comma in? Do you understand that's a silly question?
Right.
Do you see me? So the comma just is an easier way for us to visualize what's going on. In fact, some of you guys are living the hard truth that in other countries they put a comma where we put a dot, and they put a dot where we put a comma. So you got to get used to doing it the other way, or else it's going to freak me the hell out. Right? So the comma is sort of like the dot in a way. It's just a nice demarcation between the thousands and million. It's an easy way for our eyes to see what's going on.
Yeah, I was just looking at the 5.1. It just says name the decimal.
Oh,
Yeah.
This is the decimal.
Okay.
This is a decimal number.
Okay.
I like it. So when they say name the decimal, they mean this whole thing. That's the decimal.
So write it out. Yeah.
If I said write 2/5 as a decimal, that's the decimal I'm talking about. Not the decimal point. This is a decimal number.
So if they give you a decimal and they say name the decimal.
Yeah, then you just have to name the place it's in. Let's do a few more.
Okay.
Yes. I like it. So if I had this. All right, what place is this in? Tenths, hundredths, thousands. So it's 26 thousandths. Right, make sure you put the
The place
TH.
it would be in is 26,000.
26.
Even though the decimal's like up there more.
No. You gotta understand. Is there any decimal here?
No.
No. I can still ask you what place the 1 is in, right? What place is the 1 in? The tens place.
Yeah.
Okay, so I can refer to this as a decimal number because it has a decimal explicitly showing up. So please don't focus too much on, when they say decimal, they mean decimal number, the whole thing, not the decimal point. Yes?
How come the 0 is not a 1? And it's
What's happening?
the 0. No, not that one right there. How come it's not a 10?
What?
The
Say,
0.
here?
No, the 0.
Here. So yeah, there's 0 tenths,
Yeah.
2 hundredths, and 6 thousandths.
Isn't it 1 and then And
No. What is this? This is the ones place.
Whole number.
This is the ones place.
There's
All
no
right,
one.
all right. So we know from before, we already know that this is the ones place. So this cannot also be in the ones place. Correct? Is that cool? You guys with me? Every place has got to be separated by a factor of 10 because we have 10 fingers. So this is the hundredths, divided by 10 is tens, divided by 10 is 1, divided by 10 is 1/10, so forth. So you know this is the ones place, right? You know that.
yeah,
I'm gonna just say it because I know you know it, or else you shouldn't really be here. So therefore, this cannot also be the ones place. It can't be. There's already a ones place. Is that cool? All right. So this is the hundreds place, right? The 4
Yeah.
Tens.
divided by 10 is the tens place.
This ones.
Tens place, right? Divided by 10 is the ones place. Divided by 10 is the 1/10 place.
1/10.
Yep.
So the other one is just 1, and the other one is 1/10.
Exactly. Because what do I do every time I take another step down? I divide by 10. And let me think about it in a different way. You ready? All right, now watch this. So whatever this is,
One.
now watch. Stay with me.
One is 10.
You guys ready? You guys ready?
1, 2.
If I add another one to it, that's 0.2 now, right?
Yes.
So if I add 1, 2, 3, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right.
One.
Yeah. Right? Because don't you get 1, 2, 3, 4, 5, 10, and then carry the 1. So that's a whole 1. Are you guys, let me stop right there. Is that decent? Let me try it again. So what's 0.1 plus 0.1? 0.2. Now add another 0.1. 0.3. Add another 0.1.
0.4. 0.5. 0.6. 0.8.
Now add another 0.1.
1.
It'll be 1.0. All right, now let me stop there for a second. Really trying to get deeper than you've ever wanted to see. All right, sounded weird, but oh well, too bad. My grammar's not the best. Right, now watch. If 10 of these make a whole 1, each one of these must be 1/10 of a whole 1. Let me let that sink in. What's up?
Yeah, that's the easiest way.
Yeah, that's the best, that's the easiest, most basic way to explain it. This must be the tens place because 10 of them made a whole 1. 10 whats makes a 1, 10 tenths makes 1. So since these all together made one whole 1, they each must be 1/10. Period. I like it. So I can do the same thing with this. Now, I'm not going to write them all down, obviously, because how many of these would I need before I make a whole 1?
100.
100 of them. I would need 100 of these, because I have to make it 0.99 and then add one more of them. So I need 99 to get 0.99 and then one more. So it would take 100 of these to make a whole 1. So each one of these must be 1/100th of a whole 1. Now, to me personally, that's just another way to explain it. So if you didn't quite get the whole, every time I take a step down in place, I divide by 10. I divide by 10. So what's the next place below 1? 1/10. 100th, because I keep dividing by 10. All right, let me stop there. I like it. Okay? So here, you guys, let's do this. Write these in words for me, okay? Ooh, I like it.
Would that be the same as on the homework when it says name the decimal?
Yes. Name the decimal. That doesn't mean I'm going to call him Fred from now on. That means give me in words what this number is saying, right? That's what that means. This is the decimal, not the decimal point. This is the decimal number they're talking about. Oh, good question. Watch this. Say that number for me. Isn't the 2 in the 10,000 spot? Well, we can consider this whole thing to be into thousands, not this is 26,000. So yeah, you go by the last digit, but then you name it 26,000. The same way we go by the last digit in the thousands place, but then we can name it 26,000. Same way. We'll do it a different way too.
3,400.
Ah,
3,400 is thousand.
I don't think it is.
No, 3,400.
all right. So this first one should be nice because it's based on one we already did.
7,000.
Yeah, tenths, hundredths, thousands. So that'd be 7. Please, dear God, don't make me take points off for you not putting the TH. Because if you say 7,000s, well, that means 7,000s. That's not the same thing anywhere near. Johnson, how much money do we have? 7,000. Oh, we meant 7,000s. Holy shit, we're in bad shape. What about this guy? Yeah. Tenths, hundredths, thousands, 10,000s, 100,000s, millions.
So 34 million or 4 million?
Yeah, so it'll be 34 millions. Oh, yeah. Now, to go back a step real quick, and because this one has the same issue somebody brought up, and I was curious if anybody had this thought earlier. We did one a minute ago, and that was 0.026, right?
Yes.
Now watch. Now stay with me. Now just watch. Remembering that decimals are really just special fractions, right? And I actually said to you, this is 0 tenths. Is that cool?
Yes.
So I almost really didn't have to write that because 0 divided by 10 is freaking 0. You guys with me? Plus, this is 2
100.
hundredths. You guys with me?
100.
Is that cool? And real quick, just to make sure you understand what I'm really doing. I'm not done with that yet, by the way. If I wanted to expand this, I could say this is 7,000 plus 200 plus 30 plus 4, right? Okay, so that's all I'm doing is I'm expanding this by place. So it's 0 tenths plus 200s plus 6,000s. I love it. Thousandths, right? Now this is 0. Is that cool? 0 divided by anything is 0. So that's out. That's just 0. It's not there anymore. Can I add these two?
26.
Not the way they are. What do I have to do to this so it's LCD with this? Multiply by 10. So this is 26 thousandths. Because the really good question was, why do we call this 26 thousandths when it's only the 6 that's in the thousands place, Jeff? Well, that's why, because the same reason what do we call this number? 26,000. Even though the 2 is not in the thousand spot, right? You guys, it's just a way to consolidate what's happening. And actually, mathematically, that's what happens. It is 26 thousandths. So you always name it according to the last decimal place. What's the furthest it goes out? Right? So here's another example.
So when you're going to the right, it's 1,000 or whatever, whatever, and then when it's to the left, it's like you normally write.
Exactly. The ths means it's underneath, right? So tens would be just a normal 7 times 10. Tenths would be 7 over 10. The part of it means it's underneath. I like that. Right? Underneath.
We'll put the TH.
Sure, why not? Underneath means as of a So the comedian talks about Ruth's Chris Steakhouse, and he's like, I don't want to answer the phone at Ruth's Chris Steakhouse. I've heard it's good. I've actually never been. But I always had a problem with their name too. I'm like, I don't want to work there either. Shit. Okay. Where do I want to go from there? I forgot. Oh. So here, how about adding and subtracting? All right, so let's start off with something nice. So if I have 1.7 plus 0.29, I don't even know what you do with the point. I mean, this is so wrong, right? What's wrong with what is wrong? Don't even write this down, so you don't even dare gravitate.
What do, on the right side of the decimal?
I have to line up the decimal spot, right? And think about why that is. The 7 is what officially? 0.7, that's 7/10. And I'm trying to add it to 9 hundredths. Oh shit. So if I line the decimals up, all the like terms line up. That's why we do it. That's it. That's the reason why you line the decimals up. So you're actually allowed to add to anything. So the right way, dear God, don't even write that shit. The right way is put 1.7, then you got to put 0.2.
Nice.
And if you wanted to, anytime there's an empty spot, math doesn't give a shit if you put another 0 there. It doesn't change it. Now, why is that real quick? 1.7 would be 1 and 7/10. 1.70 would be 1 and 70 over 100. Aren't these the same thing when this reduced to this? So if I add zeros and zeros after a decimal, math didn't give a shit. So here I didn't really have to add it. But when I'm subtracting, you might realize I desperately have to add it. Right? So here I'm just adding, so I'm going to get what? 1.99. I like it. So it's all about just lining up that decimal place. It's all about the place. Oh shit, Jeff. You did not just say that. I have to apologize for myself.
And it was recorded.
Oh. I try to make a song about area of a triangle. 1.5 height times base. Half height. I never did finish that. So what about if here's the more difficult problem. If I had 5.7 minus 3.92. This always trips people up because of what I just said. So you have to line the decimal place up.
Yeah.
There's no question about that.
And 0.
And you want to put the larger number minus the smaller number, right? So you can't do like this just because there's another digit. Does that make sense? You can't escape it like that. You just have to put a what here? 0. And now it looks like normal. So adding, subtracting decimals only get hard, and it's not even if it's missing a place somewhere. You just put a 0 there. Because what's in that place? Nothing. Okay, 0. And now, like I heard somebody say, what do you do?
Borrow from the 7.
Check one.
Yeah. So if I borrow from the 7,
6
and then I have to
Yeah.
borrow from the 5,
Four.
so now I get 1.78.
8.
Cool.
1.78.
You guys with me? A little bit? All right, so adding, subtracting is not that different.
The
Yes.
zero is put to 10.
The 0's now 10, yes.
10. Yes.
Yes. 16 minus 9.
16.
7. Okay. Well, if the decimals weren't there, wouldn't that be the same work? Right? Same work. All right, there's decimals there. All right, well, all right. So where do things get freaky is when you multiply and divide. That's where things get freaky. So right now, today, I'm sort of doing an overview of several things with decimals. I just want to kind of get a feel for where everybody is. I got a little handout like I always do that we're going to work on here in a minute. I just want to go over multiplication first, and then I'll unleash you on this worksheet. Let's do something. What's 2/10 times 3/10?
6 cents.
6 hundredths, because 10 times 10 is 100. When you multiply fractions, you multiply across.
Before 2 with the 10, 1, 5.
Sure, but I want to keep it. Now, do you understand what I'm trying to do here? I'm trying to keep everything in terms of decimals. Are you guys with me? So I don't want to reduce my fractions at the moment. I could. That's what I normally would do. But I'm trying to make it relate to decimals. So 2/10 times 3/10 is 600. So you guys understand it. So if I write them as decimals, the answer has to be the same. So this is claiming that, how do I write 2/10 as a decimal?
1, 5.
No.
0.52.
No. What's happening? Okay.
It's just
Oh, that's
answering.
0, 0,
Yeah. So how do I say this?
That's
3/10. So how would I write 2/10?
0.2.
0.2.
0.
I think some of you guys are thinking the 2, like 1/2 is 0.5. Well, 1/2 is 0.5 because 1/2 is 5/10, right? Which would be 0.5. So
The other one would be 0.3, right?
yes. Now how do I write 600ths? No, how do I write 600ths?
0.06.
So 0.6 might be what you assume this to be. And you would be wrong. And we see that you would be wrong. Now real quick, let me just go through something before I get to the real heart of how to do this. What is 3 times 0.2? What is just 3 times 0.2? 3 0.2s, 0.6. Let me stop there. Is that cool? 3 2s is 6. So 3 0.2s would be 0.6. Is that cool? Some of you guys are like, I have no freaking idea, man. So 3 times 0.2 means 0.2 plus 0.2 plus 0.2, right?
Right.
You really want to drill it down to basics. That's what 3 times anything means. And what's 0.2 plus 0.2 plus 0.2? 0.6. Okay. Therefore, 0.3 times 0.2 cannot also be 0.6, right? Because 0.3 is smaller than 3. It's a lot smaller than 3. So 3 times 0.2 is 0.6. Is everybody cool with that fact? 0.3 times 0.2 cannot also be 0.6 because that already is. I'm dividing by another 10. So what you do is this. Here's what you do. Here's what you do, guys. This is kind of nice what you do. What made this go all the way out to this place is the fact that the bottom became 100, right? So I had to go out 2 spots. Does that make sense? Hundredths is 2 spots out. If I say that, is that cool? Tenths is 1 spot out. Okay. So what you do is, if you have a 0.2 times a 0.3 problem, 2 times 3 is 6. And then you count the total number of places in your problem. So like 1, 2, 1, 2, 0.06. Now what does that do? You're counting the number of tens. 2 tens make 100. So you got to go 2 spots back. So if I had, for example, I had 0.07 times 0.3. Well, what's 7 times 3?
21.
See, the first thing you do is screw the points, screw the decimals. You worry about that at the end. 7 times 3 is 21. So it's going to be some kind of something 21. So 21. How many total places do I see?
3.
1, 2, 3. So 1, 2, 3. 0.021.
21,000.
Yeah, so let's see. Let's see if we agree with that. If I write these as fractions, it better be that. Or else we can throw all this shit out and leave early. Yes, ma'am. Say again? Oh, good. I love it. Addition requires exact like terms. Multiplication, no way. Right? can I multiply 7/100ths, right? Is that cool? 7/100ths
Yeah,
Yes,
times 3/10.
yes.
yeah.
Of course I can. Do I need to make an LCD? Of course I do not. Right? Because what is 7/100ths times 3/10? 7 times 3?
21,000.
100 times 10? Does it match up with what we got?
Yes.
Yes. So that's this process. This counting 1, 2, 3 is this process. 1, 2, 3 zeros. 1, 2, 3 zeros. It's just another way of organizing. So I don't have to always write fractions, dear God. I just have to count decimal places because that's related to the fractions. All right? Let's do another.
It's easy.
Be quiet now. I never want to hear anybody say that because everyone's got different levels of understanding. I was in art class. If the guy next to me who'd been painting since he was 3 and said, this shit is easy, I would have slapped the shit out of him. Because I'm like, I haven't painted until today. So shut up. So be careful when you say something like that. And not everybody else is in the same place. Cool? Let me see. What about if I have 1.12 times 0.6? So now I can just, the first step is forget the decimals are there because that's the last thing you worry about. Is the decimals, right? Because what did it's relate? Remember, what's the first thing we did here? 7 times 3 is 21. And then we did these, right? So see how that's related to this. I'm going to just look at the tops, the 112 times 6. So here I get,
12.
yeah.
6.
All right, now I said, that can't be the answer, right? So now I say, okay, 1, 2, 3. 1, 2, 3. 0.672. And take a step back. Isn't 1.12 basically like 1? 1.12, if you had to round it, really round, it'd be 1.
Yeah,
right? If something cost $1.12, and now I said, about how much is that? It's about $1, right? And this is 0.6. So what's 1 times 0.6? What's 1 times 0.6? 0.6, right? 1 times anything is that thing. So look at the answer we got. 0.6 basically, right? What's the extra little shit? Because this wasn't really 1. This is 1.12. But this is still about 1 times 0.6 should be about 0.6. So that's why the answer makes sense. With the decimal ending up where it did makes sense. Okay, maybe.
So let's say, for example, like you dividing, like you multiplying, like $1. Let's say, like one is, like $1 and like 12 cents.
$1.12, sure.
Yeah.
Sure.
And like multiplying.
So this would be like 60% of $1.12. And I know percentages are still in our future, but that probably would be the best interpretation of this. Like somebody's going to give me 60% off of something that's $1.12. Ooh, right? But still, that would be a kind of a real life example of when you would have to be able to do this. Yeah.
Using it as like the 3 top numbers are 3, so you move 3 to the.
No. All right, you ready? So what if it would have been 1.12 times 0.006? It would still have been 672. Are you guys with me? It would have still been 2176. But now 1, 2, 3, 4, 5.
2, 0.
Right? 1, 2, 3,
2, 0.
4, 5. I like it. And then another one out front if you want. So it had nothing to do with the top alone. It has to do with how many total decimal places there are between the two of them. Okay, maybe. Because again, how do I write 1.12 as a fraction? You could write it as 1 and 12
100.
hundredths. I love it. Or, what would it look like as a mixed number? As an improper fraction.
112 over 100.
112 over 100. Thanks for understanding. All right, so that's one of them, right? And what about 0.006? What is that as a fraction? That's 6
1,000.
thousandths. So this would be 112 over 100 times 6 over 1,000. You guys kind of with me? What's great about multiplying things that are based on 10 is the answer on the bottom is going to be 1, 2, 3, 4, 5 zeros. 10 times 10 is 100, 2 zeros. 10 times 100 is 1,000, 3 zeros. You just count the total number of zeros, and that's the total zeros in your answer. That's a beautiful thing about 10. At the top will be that 672 that we keep getting, right? That's 112 times 6. So that's why the 672 doesn't change just because the decimals moved over. It's the bottoms that change when I move the decimal over. Do you guys see that? Which means if I make them further and further back, it has to go further and further out. So is this, what is this? Tenths, hundredths, thousands, 10,000s, 100,000s. And see, that's 100,000s. 100,000ths. Okay, how are we doing? Stop. So even if you don't understand exactly why it works the way it does, really, that actually makes me a little sad, but you got to really think about it. You got to think about why this makes sense. These are just fractions over some number of tens. So the more tens they're over, the more tens are going to show up in the answer on the bottom. All right, maybe. But even then, if you don't quite get it, you just got to count the number of places and count back that many places. That's it. So the actual nuts and bolts of how to do multiplication of decimals, beautiful. So beautiful. So watch. Let's do a couple problems in a row. So here, do these two. What you got, Jeff? I forgot. Oh yeah, yummy. All right, just do that one. You guys are like, there's no decimals. I don't care. Do that. I'm going to do that. Hopefully you guys understand. There's really just one problem up there, but we'll see what happens. There really is just one problem. Sneak this in real quick. Is that right?
2, 3.
All right, that's that one. And real quick, here's something that really is kind of... Yes, ma'am.
Shouldn't it be 3, 3?